Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published just yesterday, June 16th, 2025. It introduces a new framework that outperforms Gemini 1.5 Pro by over 7% on a new benchmark for understanding ultra-long videos. The paper is titled Ego-R1, Chain of Tool Thought for Ultra-Long Egocentric Video Reasoning. So the core challenge is making sense of extremely long first-person videos. We're talking days or weeks of footage. This paper's approach uses a process called chain of tool thought. This is where an agent learns to break down a complex question into smaller, manageable steps and then dynamically pick a specialized tool to solve each one. As we'll see, the results are quite impressive. Also, the authors shared their complete research framework on GitHub. If you head over there, you'll find the code for their agent, the scripts for generating the chain of tool thought data, and the full dataset itself. It's a comprehensive package for both supervised fine-tuning and reinforcement learning. Alright, so this first figure gives a great overview of the whole process. It shows the Ego-R1 agent tackling a question like, who was in front of me last on an escalator? To answer, the agent uses its toolbox. First, it uses a tool called hierarchical retrieval augmented generation, which creates text summaries of the video to quickly find the right day. Next, it uses a vision language model, which is like a magnifying glass for individual pictures, to analyze a specific frame. By combining these, the agent finds the event and correctly identifies the person. So how do they train this agent? Well, this diagram shows their two-stage approach. First is a process called supervised fine-tuning, or SFT. Here, they teach a base model the fundamentals of tool use by showing it thousands of correct examples. Then, in the second stage, they use reinforcement learning, or RL. The agent tries to solve problems, and a reward model gives it positive or negative feedback. This trial and error learning, using an algorithm called gradient regularized policy optimization, optimizes its complex reasoning skills, creating the final Ego-R1 agent. Okay, so how does that two-stage training actually perform? Well, this table lays out the quantitative results. We can see Ego-R1 compared against other models on several video question answering benchmarks. The most important one here is the new Ego-R1 bench, which uses those ultra-long 44-hour videos, and the results are clear. Ego-R1 scores 46%, beating even Gemini 1.5 Pro by a significant margin. It also performs very well on other benchmarks, becoming the best among open weight models, which are models whose internal designs are publicly shared. Building on those results, this table performs an ablation study, which is where researchers test their system by removing components to see what breaks. It really shows why that two-stage training is so important. Using only reinforcement learning results in 0% accuracy. The model needs the initial supervised fine-tuning to learn the basics. That first stage alone gets accuracy up to 34% and perfects the format accuracy, which is the model's ability to correctly call its tools. But combining both stages is what pushes the final task accuracy to that winning 46%. So to wrap things up, the big takeaway here is how Ego-R1 effectively tackles these ultra-long, first-person videos. Its chain of tool thought process, where the agent breaks a problem down and dynamically picks the right tool, proves incredibly successful. And as we saw, that two-stage training is essential, with supervised fine-tuning teaching the basics and reinforcement learning honing its complex reasoning. This hybrid approach really paves the way for more capable and robust AI assistants. That's all for today's AI Research Roundup. Thanks for tuning in.